Good morning everyone. Today we'll be doing class 7 physics and we'll continue with what we have been learning from the chapter heat and temperature. So in the first class we learned about temperature, different scales of temperature, how to convert one scale into another. Then we learned about heat and the difference between heat and temperature, and the different processes involved in this change of state of matter and how the processes takes place. Today, as I told you in the last class, that we will be discussing more about evaporation. Okay, so we discussed about vaporization, which is a process in which a liquid converts into gases by absorbing the heat. And there are two types of vaporization. One is boiling, the other is evaporation. And we discussed about the difference between boiling and evaporation. Evaporation is a slow process, boiling is a fast process. So today we will be discussing more about evaporation. Okay, so what is evaporation? Evaporation is a process in which a liquid changes into gases at all temperature. I told you in the previous class that evaporation takes place at any time. It's taking place right now, it takes place in the evening, it takes place in the morning, at any temperature, it always takes place. And it's a surface phenomenon. Now how does evaporation take place? Now see here, evaporation occurs when the particles of the liquid absorb heat from the surrounding. Now remember this, during evaporation, heat is provided by the surrounding. Okay, for example, you put a glass of water or just sprinkle water on the ground, and after you come back after some time, what will you see? Either you see very less amount of water on the ground or no water at all, which means all the water has been evaporated. And how did it evaporate? It absorbed the heat from the ground. Okay, so it absorbed the heat from the ground and then it evaporated. So that's why evaporation occurs when the particles of the liquid absorb heat from the surrounding. The absorption of heat increases the energy of the particles of the liquid. So I have told you this earlier, if the particles of an object absorbs heat, the kinetic energy increases, which means the particle starts moving faster. Okay, when the particle starts moving faster, the intermolecular force becomes weak. That means it becomes weak and the particles will start moving apart. And as the particle starts moving apart, their intermolecular space increases, and thus the liquid particle changes to gaseous particles. And they escape the liquid surface into gaseous form. Since the particle of liquid absorb heat from the surrounding, the amount of heat present in the surrounding decreases. Please remember this, since evaporation is a process in which heat is absorbed from the surrounding. Like I gave you an example, if water is sprinkled on the ground, the water absorbs the heat from the ground and it evaporates. And when it evaporates, what happens? It's absorbing the heat from the surrounding. That is why its temperature decreases. The temperature of the surrounding decreases, which causes cooling in the surrounding. Okay. Now, what is evaporation? So we will be discussing some of the examples related to how evaporation causes cooling. As I told you that during evaporation, heat is absorbed from the surrounding. So when the surrounding loses heat, its temperature decreases, which means it causes cooling. Now in fact, it's the oldest known method of cooling hot and dry air to make living or walking spaces more comfortable. Now, in ancient times, Egyptians hung wet materials so that wind could blow in to create a cooling effect. This was the ancient method, okay, where the Egyptians, they used to hang wet cloths on outside, so when the wind would just flow through those wet clothes, okay, the wet cloth, that is the water in the wet cloth, will absorb heat from the surrounding and evaporate, thus creating a cooler atmosphere, that is cooler surrounding. Okay. Another example of evaporation causing cooling is surahi, that is your clay pot. You know this is your clay pot. Okay, now you all must have seen clay pot, isn't it? If you don't use it often, it is also known as earthen pots. We don't often use it these days, but you might have seen it either on TVs or mostly in the plain areas you've seen it, isn't it? So those surahi, those clay pots, the earthen pots, they are used to store water. Why do they store water in earthen pots? Because the earthen pots, they have very minute pores, okay, they have very small holes. Minute pores because they have very small holes. And what happens is, the water, they absorb the heat from the surrounding through those pores. Okay, they absorb the heat from the surrounding through those pores, and they start, once they absorb the heat from the surrounding, they start evaporating. And when they evaporate, they decrease the temperature of the surrounding. So this is how evaporation causes cooling in earthen pots. Now, why do swimmer feels cold after emerging from pool? This is, we all have experienced it, isn't it? Once you are like on a very bright sunny day, we go to swimming pools, we enjoy the water, and then when you come out of the swimming pool, you kind of feel cold, right? Why? Because your body is wet when you are on the water, when you are inside the water, your body becomes wet. Now, as you come out, what happens is, the water which is on your body, okay, they evaporate, taking heat from your body. When they evaporate, taking heat from your body, what happens? The body temperature becomes lesser. And when the body temperature becomes lesser, what happens? We have this cooling, or we feel cold. Okay, so this is why we feel cold when we come out of the swimming pool, because the heat is absorbed from the water, by the water from our body to evaporate. So here, water removes heat from our body 7 times faster than air. So when we get out of the pool, our body is wet. Because the water at the surface of our body begins to evaporate, and evaporation causes cooling. As I told you about the earthen pot, so earthen pot keep water cool even in hot summer days. So as I told you, they have very minute pores. Okay, why the water which is kept on a still not so cold compared to the water which is kept on a mud pot or a clay pot cooler compared to the water which is on a still? Because they have minute pores, so they take heat from the surrounding. Okay, and thus they start evaporating, and as they start evaporating, they are losing heat. Okay, when they evaporate, they are losing heat, which means the water becomes colder. Now, another example is evaporation is a process by which water changes from a liquid to gas. We discussed that. Now, another one is sweating. When you sweat profusely on a very sunny day, when you are outside, just go outside and then you start perspiring, you start sweating, isn't it? And you just stand in, either when you wipe it or when you stand in front of a fan, what happens? You feel that cooling effect, isn't it? Why? Because the water, the sweat, is in the form of water, it's in the form of liquid, isn't it? So the sweat, they take heat from our body in order to evaporate. When the wind comes, what happens? The water evaporates. And how do they evaporate? They take heat from the body. So when they take heat from the body, we get the temperature of the body decreases, causing cooling effect. Okay. So this is how sweating happens because of evaporation. So these are the various examples of evaporation. So how evaporation causes cooling. You've seen those dogs panting their tongues out, isn't it? They pant their tongue out in a very sunny day. Why do they do? So that the saliva on their mouth, okay, they evaporate, taking heat from their tongue. So when the heat is taken from their tongue, the body temperature decreases, thus they feel cooler. Okay, that's why on a very hot summer day, you might have seen dogs panting their tongue out. It is also an example of evaporation causing cooling. So there are many examples related to that. Now we will be discussing about factors affecting evaporation. Now evaporation depends upon 5 factors. First, temperature. Second is surface area. Third is humidity. Fourth is the speed of the wind. And the last one is nature of the liquid. Now temperature. If the temperature increases, the rate of evaporation also increases. The best example, clothes dry faster on a sunny day than on a rainy day, isn't it? Why? And also on a cool day. Okay, forget about the rainy day, let's talk about sunny day and cold day. So clothes dry faster on a sunny day than on a cold day, because on a sunny day the temperature is high. So when the temperature is more, the rate of evaporation will also be more. Okay, so when the rate of evaporation increases by the increase in temperature. Number 2, surface area. Now you serve a hot rice, you can say hot rice on a plate, okay, on an open surface plate and a bowl. Now you know plate is flat and open, and a bowl would not be as flat and not open compared to the plate. So you keep it for half an hour. Which one will cool off faster? Obviously which is on the plate, because it has open surface area. That means more the flat surface area, more will be the rate of evaporation. Okay. Humidity. Now we'll come to the rainy day. Clothes, you know, clothes they don't get dried easily on a rainy day, isn't it? You have piles and piles of wet cloths stacked up on a rainy day than on a sunny day. So it doesn't just, on a sunny day the cloths just dry in no time, like 1 hour, 2 hours the clothes dried up. But on a rainy day they take a lot of time, because on a rainy day it's already humid. That means the water vapor is already present on the atmosphere, in the air. That's why the air will not be able to absorb more water. Okay, they will not be able to absorb more water vapor from the cloth. But on a sunny day, it's less humid, means less water vapor. Thus, it will be able to absorb more water, and thus cloths get dried up faster on a sunny day than on a rainy day. Because on a rainy day, it's humid. That means humidity is more. So if the amount of humidity increases, rate of evaporation decreases. Okay. The next factor is speed of wind. You know, on a windy day, clothes dry faster. Okay. Then on a cold day, because winds they tend to increase the rate of evaporation. So wind need kinetic energy to flow. If the speed of the wind will be more, then the kinetic energy and temperature will also be more. So the rate of evaporation will also be more. Now the last one is nature of liquid. There are 2 types of liquid. One are called volatile liquids, the other one are called non-volatile liquids. Volatile liquids are the ones which vaporizes very quickly, and non-volatile are the ones which takes time to vaporize. Example of volatile liquid would be alcohol, ether, spirit. You know spirit, when you just put it in your palm and then you feel that cooling sensation, because they vaporizes very quickly. On the other hand, when you keep water on your palm, it takes time to vaporize, isn't it? So spirit is a volatile liquid, whereas water is a non-volatile liquid, which means there are liquids which vaporizes very quickly, and those are called volatile liquid. So depending upon the nature, okay, if it's a volatile liquid, rate of evaporation will be more. If it's a non-volatile liquid, rate of evaporation will be less. So these are the 5 factors in which rate of evaporation depends. The first one is temperature. With the increase in temperature, rate of evaporation also increases. Second one is surface area. If the surface area becomes more flatter or increases, rate of evaporation also increases. The third one is humidity. If the amount of humidity increases, evaporation decreases. Okay. The fourth factor is speed of wind. The speed of wind increases, rate of evaporation also increases. And the last one is nature of liquid. And depending upon whether it's a volatile liquid or non-volatile, it depends upon that, the nature of the liquid. If it's a volatile liquid, rate of evaporation will be more. If it's a non-volatile liquid, rate of evaporation will be less. So these are the 5 factors in which rate of evaporation depends. So with this, we complete the entire chapter. So we've completed the chapter heat and temperature, and whatsoever question and answers are there in the question, the text, in your exercises, please do it. You don't need to do the objectives, only the questions and answers. Thank you and have a good day.